What jumps out at you in this article? What jumps out at you in this article? What jumps out at you? Go ahead.
No, the .001 does for sure.
.001, that's on the back there, Eric?
Yeah, it's down to the last paragraph.
There you go. The p-value jumps right out at you. First thing he sees P is less than .001. So, generally, or generically saying, forgetting the context of the paper for a second, you see a p-value of .001, what does that imply? What happened during your experiment? Be as general as you can when you answer this question.
I'm guessing it means it's highly significant.
Good. It's highly significant. Whatever you were studying was significant. But you went into the study assuming that it wasn't going to be. That's the whole idea. It wasn't going to change. You went into the study saying, you know what, drink all the green tea you want to drink. And guess what? It's going to have blank effect on breast cancer. Fill in the blank. No effect on breast cancer rates. Drink all the green tea you want. Drink all the green tea you want. It's going to have zero effect on breast cancer rates. That's what we went into the study expecting. That's your null hypothesis. Did you catch this in the second paragraph? Tea polyphenols, particularly green tea polyphenols, have been shown to possess anti-carcinogenic effects against breast cancer in experimental models. Blah blah blah. However, data arising mainly from Western populations are not supportive of a protective role of tea in the prevention of breast cancer. Most of the studies yielding null results were conducted in Western populations that consumed exclusively black tea. So in other words, they've been trying to do these studies in America or Europe. I think Europe is considered Western, yeah, I think. So European, Western, but because we consume so much black tea, we're losing the polyphenol argument. So the yielding null results means what kind of p-values were they getting in those studies? Big ones. How do we define big again? Big p-value? Above 5%. We were getting p-values above 5%, which means, well, black tea is not fighting breast cancer. Well, black tea is not fighting breast cancer. This isn't the argument of this article. This article argues that black tea does not fight breast cancer, or we don't care if black tea fights breast cancer. We care if green tea fights breast cancer. Yes. Fantastic. Is that fair? See the difference there? So that when you see that yielding null results, they're talking about that. Did anybody get upset by this? A proportion of lost or non-responding patients was about 1.2%, similar to the percentage among the controls. Please, Cassie?
Does that mean they died? What does that mean?
They could have died. That's lost could mean died. Lost could mean they just stopped coming back for follow-ups. That's, just so you know, that's damn good. I have done plenty of research for people working on their PhDs where more than half of their data disappears. And not by death, just because they get tired. A lot of them are A/B studies. They'll measure them, and they'll make them do something else, and then measure them again. People are like, you know what, you're not paying me for this. I'm not coming back. They just get tired of it. So 1.2% lost is not bad. Death could be one of it. As a matter of fact, attrition could very easily be. Did they mention how long this study was?
2004 to 2005.
There we go, a 1 year. 1% death in 2004 to 2005 is fairly, I think, believable. So that could very well be just from death and or just from non-response. Okay, next down there, potential control women were excluded if they had a previous diagnosis of either breast cancer or another malignant disease. Wrap that up in one word. What are they trying to mitigate by excluding control women if they had previous diagnosis of breast cancer or some other malignant disease? Use one word. What are they Good! I wasn't thinking. That was the second word. Drew, bias. We're trying to eliminate bias. I was thinking of a word that started with O. We're trying to remove outliers. Because if we throw an outlier like that in, that can unfortunately inflate the percentages. But bias is much better. We're controlling for a variable. I like that. I like bias better than outlier. So we're basically just trying. We're trying to keep the study as unbiased as possible. In other words, we're trying to maximize the showing of the effect of green tea on the breast cancer rates by removing anything else. Fair? Ish? Okay. Of course, a big argument for this is it was done in China. And an obvious argument is what?
They have a different diet.
They have a different diet, not just green tea, but also a different diet. One of the saddest things I've heard about is the Chinese diet is changing. And Chinese lifestyle is changing as it becomes more westernized. I was going to say McDonaldized, right? They're consuming more fast food, We're seeing more incidences of heart disease pop up in Eastern, where it used to be predominantly fish and rice-based diet. Now we're getting fast food. If you looked at a picture of Beijing, say 30 years ago, it was all bikes and 3 cars. Now it's all cars and 3 bikes. It's a lifestyle change. So you have to kind of somehow weight that. However, if everybody in the study participates in that lifestyle, you've controlled for that variable, haven't you? It might be a higher breast cancer rate now than it was in, say, 1986. But the breast cancer rate from the control group to the experimental group should still show a deviation if this is the only variable. In other words, green tea consumption. Fair enough? Did they define green tea consumption in the article? I don't remember. Was it a certain amount? No. I know it's in the article, I just didn't copy and paste it. So I'm assuming you have to drink a certain amount of it in order for it to kick in, so to speak. Yeah, but again, I give you the links to all of these things if you want to check it out. All right? Now, I want to give you another symbol here. A little symbol. What is this study trying to show? What is it trying to show?
Green tea will reduce.
Boom! That green tea is going to reduce breast cancer rates. Now, that's called the research hypothesis. We generally call that H1, which for hypothesis 1, I forget what your book calls it. It might call it that. It might also call it HA for alternative hypothesis. I don't know which one it uses. It doesn't matter. You'll see them both in the research that you guys consume. Either one of these is the research hypothesis, and the research hypothesis is breast cancer rates are reduced with green tea consumption. There is your research hypothesis. That's what you're interested in seeing. Eric has already identified the fact that it looks like they are, based on your p-value. We'll come back to that. We'll come back to that. It's important. We're going to wrap up with that today. So, if that's your research hypothesis, what's your null, which is H0? That's uniformly called H0. It's usually not called anything except that. What's your null hypothesis?
That has no effect.
That has no effect. Good. On lowering. So, and here's the thing. You see how I use the word reduced? I'm going to put green tea does not reduce. And Rosie, I love what you said. Has no effect. Green tea consumption. I'm just going to put does not reduce cancer rates. Breast cancer rates. Yeah. Why do we care about breast cancer?
Save the boobies.
Why do we care about breast cancer? Save the boobies. Why do we care about it?
People die.
I believe it's the #1 killer of women. I believe. Heart disease might have eclipsed it now, I'm not sure. But I believe breast cancer, at least in America, is the #1 killer of women. I believe. Misdiagnosed, undiagnosed.
The largest cancer group.
The largest cancer group, there we go. Compared to other cancers. Okay? So, we care about this, obviously. Obviously. You always hear about mammograms after age, whatever age you're supposed to start getting them. And there's a reason for that. It's because if early detected, it's also, I believe, one of the most preventable. Compared to like pancreatic cancer and awful cancers like that. So we care about this. So if we can have some kind of a dietary, easy to follow regimen that helps us lower it, hell yeah, let's get on that. Now, the reason I put does not reduce. Now, the opposite of lower, in your mind, is not lower. It could be possible that drinking green tea would actually elevate breast cancer rates. I mean, God forbid. Well, then we know not to drink it, obviously. We know not to drink green tea. But that's the opposite of does not lower, is no effect at all, or potentially even raise. Or potentially raise. You want to go with the mathematical opposite. That's why I'm kind of harping on that. Is that fair? I just realized the camera's pointing in the wrong place. There are our hypotheses over there. I did that GPS thing I told you guys about. You wear it in your pocket, and it sits on a little stand, and the camera follows you around as you move back and forth. Maybe I should get one of those. It's a pretty trick. It's a pretty trick. The problem is I move so much that you might never be, like motion sickness. So there are our hypotheses, and the screen, that's interesting. The screen is showing things backwards. I hope it's actually recording properly. I'm sure it is. They're clever.
I'm sure if you turn the background,
They'd be correct.
yeah.
All I know is my tongue was just sticking out and the thing zoomed into my face. You guys, you deserve a medal for sitting through this class. All right. Let's get back into this. Let's get back into this. We got our hypotheses now. I'll worry about symbols momentarily, but what I really want to talk about right now is Eric's p-value of 1 in 1,000. 1 in 1,000. Okay, so here are the cancer rates in the population. How the hell do we know that? How do we know what those cancer rates are? How ballsy of us to say that. How do we know this?
People that have cancer usually go to the doctors.
So we have records of them, yes? I love it, Danielle. We have records of cancer in the population. We also can form ratios in many ways, those that go to the doctor and report cancer versus not reporting cancer. Yes, cancer is generally very well reported, because by the time it gets to the point, unfortunately sometimes it's too late,
Still reported.
but it's still reported, so you have a record of it. And then you can form a ratio, you have a record of the cancer, hopefully the ones that you don't hear about and somehow suffer from cancer without ever knowing a doctor are underreported or very, very close to zero. You've got a population, you've got those reported, you have yourself a ratio, there's your cancer rate. And because you have a cancer rate, and because it's binomial, you also have a margin of error around it. Beautiful. So, those cancer rates, though, are in the general population, which means there's no green tea influence on those cancer rates. That's what we want, because we can get that data. Then, once we have this parameter population, if you will, we can develop the sampling distribution for our study. So, here's what we're expecting. We're expecting, here's our 95% one-sided confidence interval. Still 95% of the curve, but it's an offset margin of error a little tiny bit. And we're expecting whatever that cancer rate is to be right about here. And where did it land? Well, I don't exactly know where, but I know by that it must have landed in this red region, and it must have landed pretty far down in that red region. Please.
Were they using people that they knew that had a background of breast cancer in their families? Because not everybody has, they're not always going to get breast cancer. Like, if it doesn't run in the family, you're probably most likely to get it.
Absolutely, absolutely. And this is the idea, is you've controlled for all of that. Everybody in the study, the only deviation in the study, and this is why I only pulled part of the study out and put it on this. I wanted to save it to one paper. Please dive in and see their sampling methodologies. Honestly, these results are gotten in 2 minutes once you have your data, but it takes years, if not decades, to actually get the data. And I highly encourage you, you'll take entire classes. Some of you may have already taken survey classes in OSU Cascades. There are entire classes devoted to just that question, or questions like just that question. The goal of any good study is to minimize those differences. So if it's true for the control group, then it's true for the experimental group. And we're comparing apples to apples, except for the fact that these guys get a little white, or in this case, caffeine placebo pill, or a caffeine pill or a placebo pill. Does that make sense? Or a green tea pill, I guess. I don't have the answer off the top of my head because I haven't read the article in 5 years. But I gave you the link in case you want to dive in there. But it's definitely a sampling methodology thing, and I'm trusting them because it's decent. Is that fair? Good, thank you, thank you. Now, we were expecting the cancer rate to be the same as the general population. Or maybe, God forbid, green tea would actually make it worse. Maybe green tea would actually make it worse. But what happened? Green tea, all things Danielle being equal, green tea apparently lowered it. Now, there's the statement. There's the statement of the p-value being less than 1 in 1,000. We were expecting green tea to have no effect, but guess what it did? No effect on lowering was contradicted by the fact that it lowered. You're expecting it not to lower, instead it lowered? That's a contradiction. How is it indicated? How is the contradiction indicated? Because we got a p-value that is...
Less than 0.05.
Boom! Less than 5%. Less than 5% means a contradiction occurred, means that we saw something unexpected. We are outside of 2 standard deviations. Now, what do you think? Is green tea associated with lower rates of cancer? Sure looks like it by this study. Here is what I want to ask you now. I mentioned before the idea of another curve. So I'm doing this a little bit shooting from the hip wise. That gray curve was the original curve that we saw, which was the non-green tea drinkers' breast cancer rates. That was the original blue curve. I changed the color because it didn't look as good blue as it looks because it was gray. See that asterisk that's right there? I threw an orange curve up there. That's an interesting curve. And I'm ballsy for doing it. Statistically ballsy for doing it. And here's why. First of all, this question. Is it more likely that this asterisk lives on that gray curve or this orange one over here? Is it more likely it lives on the gray curve or the orange one? From a pure probability standpoint, what do you think? Which color?
Orange.
Most likely orange. Well, how do you answer? You answered very, very confidently. Tell me why. I love it. What are you looking at in particular? Just out of curiosity.
The asterisks will lie within 2 standard deviations of the average.
I love it! This curve's average is closer to that asterisk than this curve's average. That means in order for that asterisk to be on this curve, it has to be further from average, which is less likely. It's less likely for it to get further from average. It's more likely that it's close to the average than less likely to the average. Unless you're expecting outliers. But what's wrong with that statement? Unless you're expecting outliers. What is the definition of an outlier? Something not expected. So if you're not expecting outliers, the data point you get should be closer than further away from average. 100% correct. I love it. Another way of looking at it is just simply look at the height of the curve above it versus that. Now, why is it ballsy for me to throw that orange curve up there? How dare I? How dare I? How do I know the gray curve is there? How do I know the gray curve is there? Now suppose there's a fixed value, and it is. Suppose I know that average rate of breast cancer in this population. Let's say it's 1.2%, just to throw a number out there. Nah, we already used that. Let's say it's 3%. 3% breast cancer rate. How can I put that up there? As Danielle said before, because we know that from reports. Why am I ballsy to slap this one down here?
But the average cancer rate's even lower than your sample.
And that's all exactly. I can't put that orange curve over there and say, I know it's right here. But what I can do, I can say I'm 95% confident that it's actually lower than it is in the general population. So in other words, I can pull the curve to the left and say, this is where I think green tea drinkers' breast cancer rates are, somewhere to the left. I'm not saying where. I'm not saying how far down with this. I'm simply saying I think it's significantly lower. Because it most likely is not on this curve. It's more likely on a curve that's down here. And when I say down here, I mean a statistically significantly different curve to the left. So it's more likely on that curve over there. The downside of that curve is I don't exactly know where it's centered. I don't exactly know where it's centered. I just know it's lower. But that's what we'll do most of the time in this class is. I won't say it's lowered by this amount, although I will have you guys explore that from time to time. Because you see that all the time. Our drug reduces headaches by 40%. I want you to know where those numbers come from. But the vast majority of the time in this class, we're going to look at simply stating whether something changed, lowered, raised, or stayed the same. So I'm a little ballsy in throwing that second curve up there. Everybody's not know what that second curve is. But I can say with 95% confidence that it is over there somewhere to the left of the original curve. Yes? Okay. We'll catch you on Tuesday. We'll do some more of this. We'll do some more finish this bad on Tuesday. We'll talk also about your exam, which is Thursday. I'll have the take-home posted for you ASAP. I'm hoping tomorrow morning, no later than Sunday afternoon. All this technology agrees with me. So don't do any homework unless you want to. I do the own homework. Make sure you've done that.
Is that the first 2 homework?
Yes, sir. That's your exam. The first 2 homeworks. I pulled the central limit theorem off there. I realized I wanted to cover it, so I jacked it off. So the first 2 out here. Perfect. You got it, brother. We'll get back into this. Get back into this next time. It's perfect time. It's most next. I should probably turn off the camera too, because I'm talking about it.